I'm Mirali Fetslan from BDA 2511. So now we move on to the next step. So we need to find out A4. For find out A4, we will use that K equals 2 and A4 then will equals 2 plus A3 then 4 by 2 then half of 2 plus 1/4 and that will be equals to 3 over 8. That is A4. So now we need to find out A5, A6, A7. We repeat the process to find the remaining terms, and for A5, it will be K equals 3, and it will be A5 equals 2, A3 plus A4, that will be 1 over 2. Now we know that A3 is 1 over 4 plus 3 over 8, sorry, and this will be equal to 3 over 8. So now we need to find out A6. For this, K will equals to 4. A6 equals 1 over 2. With 3 over 8 plus, wait, no, I have a mistake here. That's, no, 1 over 2 to 5 over 8, and that's, it will be 5 over 16. That's why my pencil did not work. It wants to say that I'm wrong. I made a mistake. So now here we will add 5 over 16, and it will be 1 over 2. Here we add the 2, and it will be 11 over 16. That will be 11 over 32. So for A7, K will be 5. Now 5. A7 equals, I closed my pencil. So here is A5 plus A6, which is 11 over 32, and that will be A2, 10, 1 over 2 by 21 over 32. That will be 21 over 64. So we repeated all these processes. So A7 equals 21 over 64. So there's all first 7 terms. So now we need to prove by, I will do proof by mathematical induction. We will use strong induction here. So now we'll use for n equals 1 and n equals 2. For n equals 1, a1 equals 1 over 3, 1 minus 1 over 2, 1 minus 1, that will be 1 over 3, here is 0, 0, 1 minus 1, that will be 0, that is true. For n equals 2, a2 will be 1 over 3, 1 minus 1 over 2, 2 minus 1, and that will be 1 over 3, 1 minus 1 over 2, 1 over 3, here will be 3 over 2, and that will be 1 over 2. That is also true. So so this is the base case, it's true. So next, for our inductive hypothesis, we assume that formula is true for all terms up to some integer e. That means we can use the formula for both. So we'll get that 1 over m over 3, 1 minus 1 over 2, and here's n minus 1. So that's it. And for the next, we need to prove that here we will prove that n equals e plus 1. Now we want to prove that the formula holds for n equals e plus 1 using our recurrence relation. A plus 1 is half of a e minus 1 plus a2. So we'll use it like a e plus 1 equals 1 over 2, 1 over 3, 1 minus plus 1 over 2, e minus 2 plus 1 over 3, 1 minus 1 over 2, and e minus 1, a e plus 1 equals 1 over 6, 2 minus 1 over 2, a minus 2, no, here, minus 1 over 2, a minus 1. So we submitted our induction hypothesis into the equal factor of 1/3. So we note that 1 over 2 e minus 1 equals to minus 1 over 2 minus 1 over 2 e minus 2 a plus 1 equals 1 over 6, 2 minus 1 over 2 e minus 2, 1 minus 1 over 2, 1 over 6, 2 minus 1 over 2 e minus 2, and 1 over 2. A plus 1 over 6, 2 plus minus 1 over 2, minus 2, minus 1 over 2, plus 1 over 6, 2 plus minus 1 over 2, minus 1. A plus 1 was 1 over 3, 1 minus 1 over 2, minus 1 over 2, a minus 1, and 1 over 3, 1 minus 1 over 2, a. This matches the formula that n equals e plus 1. So this perfectly matches our formula, and there is the proof. It's completed. The proof is complete. Now we will move to the exercise 12, and for exercise 12 I will write the slowly. Now here so on the exercise 12 we firstly need to find first terms of sequences. We need to find the first term of sequences. Let's find the first 5 terms of the sequences, given that a0 equals 2, a1 equals 3, and the formula. So here n equals 2, a2 equals a3a1 minus 2a0 equals 3 plus 2, it will be 5, 9, 5, n equals 3, it will be a3, 3a2 minus 2a1, and that will be 3 to 5 minus 2 to 3. Here will be 15, 6, it's 9, and the n equals 4. A4 equals 3a3 minus 2, 8, 3 by 9, 2 by 5, 27 minus 10, 17. So first 5 terms is 2, 3, 5, 9, 17. So now we'll move to B. For B, we need to guess the formula of an. So let's look at the differences between all our part of the sequence. Here we can show that a0 equals to 2, which we can write like 2 to the power of 0 plus 1, that will be 2. 1 will is 3, that's 2 or power of 1 plus 1.
Yes.
And 1, 2 equals, it's 5, that will be 2 power 2 plus 1. So here we can see that an is equals to 2n plus 1. Now we move to the C. On the C we need to verify that B is correct. Our guess on B is correct. So for proving, we use induction. I'm sorry. The base cases for n equals 0 and n equals 1. For the inductive step, we submitted our guesses formula into the relation, explaining and simplifying the terms. So let's try it. Like ak plus 1 equals 3 ak minus 2 ak minus 1 equals to a2 k plus 1 minus 2 2k minus 1 plus 1 ak plus 1 3k plus 5 minus 2 k minus 1 minus 2 k plus 1 equals to 3 to the power of k minus the power of k plus 1 equals to the power of k plus 1, that will equals to k plus 1 power of k plus 1 plus 1. So verified, we get 2 times 2 to proof of k plus 1, which simplifies to 2 to the power of k plus 1 plus 1. The guess is verified. And D, on the D, find the formula for an that involves only one predicting term. So we know that a n equals to n plus 1, that equals to n power of n equals to a n minus 1. Also we know that a n minus 1 equals to 2 power of n minus 1 plus 1. So n power minus 1 equals to a n minus 1 minus 1. So that means that 2 and the power of n equals 2 power of n minus 1, which we can write a 1 minus 1, a n minus 1 equals to a n minus 1 minus 1, a n minus 1 equals to a n minus 1 minus 2, a n equals to a n minus 1 minus 1. So solving. So now we move to the chapter 6, and we will with sector 2 and begin from the exercise 6. So for the exercise 6, we need to find for in A how many 5-letter palindromes can be made. So for part A, the 5-letter palindromes looks like A to B to C to then B and to A again. So this means the first 3 letters completely determine the last 2 letters. So here's since there will be 25 letters for the first, because in this English alphabet is 25 letters, and there will be 26 possible variants choices. So for the second also, and for the third, second, and for the third, there also will be 26, so 6 choices. So, and for the first, for the fifth letters, there will be only one choice that is made it here. So in total, we'll get 26 to 26 to 26. See also to 1, that is 26 over 3. That is, we'll use calculator. That is 17,576. So that is the answer. Now we will move to the B. For B, we need to find how many 8 letters are possible. So it will be in the form like A, B, C, D, D, C, B, A. Just like before, only the first 4 letters can be chosen fiddler. So that it will be just 26 over 4. That is 76. So now we move to the C. In C, we need to find how many words not exceeding 8 letters in length are palindromes. So for the length A, from 1 to 8, from 1 it will be 26, for the 2 it will be also 26, for 3 it will be 26 over 2, that is 676, for 4 it will be also 676, for 5 it will be 56 over 3, and 7,576, for the 6 it will be the same, 7,576, and for the 7th it will be 456, 976, and that means that for the 8, the same, it will be 456 and 976. So we need to find out the total sum. The sum is 2 by 26 plus 2, 26 over 2, power of 2, plus 2 to 26 power of 3, plus 2 power of 26 and the power of 4. So that will be 2 by 26. We will also выведем за скобки 676 plus 7,576 76, which is 2 which is 957 and 508. So that is the answer. Now we will move to exercise 10. For the exercise 10, we are finding the total number of 7-digit telephone numbers under the certain restriction. For the first 2 digits, the range is 2 through 9. From 2 to 9, it's the first and the second. Here is 8 choices. 2 to 9. For the third, it's a 9 choices from 1 to 9. For the first, it's on 10 choices. And it's not only for the fourth, it's only choices from 0 to 9. It's for the first, 5th, 6th, and 7th. So in total, it will be 8 to 8, 9, and 4 times 10. That is 5,760,000. So now we'll move to the exercise 12. Exercise 12. Now we want to select the adjacent squares from an 8 by 8. Chessboard sequences. Squares can be adjectived either horizontally or vertically. Let's count the horizontal pairs first. For the horizontal pairs, each row of 8 squares, there are 7 adjustment horizontal pairs, so it will be 8 to 7, that is 56. And for the vertical pairs, it will be the same, that is 56. So in total, we need to sum up this, and that will be 120. So that's all. Now we'll move to the exercise 15. So in the exercise 15, we're looking for the 3-digit numbers that must contain the digits 2 and 5, but cannot contain 0, 3, or 7. So let's look at our pool of available digits, excluding 3, 0, and 7, of course. So we'll have that here is 1, 0 is not included, 2, 4, 5, 6, 8, and 9. So total available is 7 digits. So total words of 3 using the 7 digits, it's 7, 7, 7, that is 7 to the power 3, that is 143. Condition A, rule is condition A, that's missing digit is 2, remaining digits, so we will excluding 2 also, and there will be still 6 digits. And that's 6 power 3, that is 260. Case B, we are missing 5. It means that here is also 5 digits available. 5 in the power of 3, that is 125. And we will sum up condition in A and B. So we will exclude 2 and 5. That's 5 digits, that will be same like just B. So 125. So numbers with both 2 and 5 equals to total missing 2 minus missing 5 plus missing both. So we will get that the answer is 343 minus 116 plus minus 216 and plus 125, that is 36. So that's all. Chapter 7, exercise 5. We have that x plus y is 20's power. So in the part A, we need to find the first 3 terms. So the 1, 2, and 2x 20, y 0. Here will be 1, 20, x 20, it's 1. Here 20, x 19, click 1, 20, x 19, y and a3, 20, 18, 19, 2, 119, x 18, so there it is. Now we'll move to the B. On B, we need to find the last 3 terms. It will be A 19, 18, it will be like 119, x 2, here power of 18, A 20, here will be 90, A 26, y 19, and A 21 is 20 or 20. X is power 0, you're in the power of 8, you're in the power of 20. So now we move to the C. We need to find the 7th term and the 15th term. So 7 equals to 20, like it's 7, 6, and x 14 equals 6. Probably have it x 14 equals 6. And a 15 is 20, 14, probably 6. 14, and x to the power of 6, y to the power of 14. Now the last is D. What is the coefficient of x to the power of 13 and the y to the power of 7? Find that coefficient is equal to 7, that is 20 factorial to 7 factorial to 30 factorial. 30 factorial to 14, 15, 16, 17, 18, 19, 12, divided by 7, and 13. Over here, that will be 37, 520. So now we need to exercise 10. So in the exercise 10, what is the coefficient of x5 in the binomial expansion of x minus 2x in the power of minus 2 power of 20. So k plus 1 here minus 10 to the power of k, and 20 power of x minus 20, x power of 20 minus k with the x minus k. K plus 1 equals 2 plus k minus the power of k, 20 x minus power of 20 minus 4k. So it's also, we want to find the terms where the power of x is 5. So 20 minus 3k plus 5 minus 3k equals minus 15. Here's k equals 5. So the coefficient will be 20 into 5, and minus 10 to the power 5. It will be minus 32. Is minus 496 and 128. So there is the answer. And the last exercise is 20. We need to find the coefficient of x to the power of 25. The binomial to x minus 3 over x to the power of 2 and the power of 58. So n equals to 58, a equals to 2x, b is minus 3x minus the power of minus 2. K plus 1, 58k, 2x to the power of 58 minus k, minus 3, x minus the power of minus 2 plus k. So 2k plus 1, 58k, 2, 58 minus k, minus 3k, x 58 minus k, x minus 2k, plus 1, k. 22, 58 minus k, minus 3k, 58 minus 3k. So we need to find out the fifth, so 5 minus 3k equals 25, minus 3k equals, so 25 plus 8, 33, k equals 10, here, 11, I'm sorry. So the coefficient here will be 8, 11, 10 4 37, minus 3 of 11. So here is the answer.